Hello, students of Chemistry 121. It's me again, Rick Morgan, your professor. I'm adding a little extra content again this week. It's going to have a few YouTube videos that describe what we're talking about this week in this chapter. And what we are talking about is ionic bonds this week. And following this week, we'll go over covalent bonds next week. And then we'll talk about chemical reactions the week after that. So we sort of have to define the great classes of chemical compounds, which can widely be divided both into ionic and covalent. And then once we understand the different types of bonds, we can understand some of the motivations for chemical reactions to occur, because the motivations for chemical reactions are very similar for the motivations for atoms to form bonds in the first place. The two types of bonds are ionic and covalent. This week's ionic again, and I'll describe to you a little bit what that's like. So let's say if we have let's say that this is carbon, it's black, and then this is oxygen, it's red. And let's say that oxygen would like to have one of the electrons that is on the outside of carbon. Well, if you have an ionic bond, the oxygen comes up here and says, hey, check it out, I want to have an electron here. Picks up an electron, slaps the carbon, takes the electron away. That's a very strong affinity for that electron. It wants its electron really bad, and so that's an ionic bond because it's made these two things into ions. An ion is something that is electrically charged, an atom which is electrically charged. So if oxygen picks up an electron, since electrons are negatively charged, it is now negatively charged, and this is now positively charged. Each one is an ion, which are sort of like action words. Action ends in ion, and motion ends in ion. Those things mean, those suffixes mean to move, and they mean ions. And then if they weren't strong enough to separate, they would share. And this little brown thing represents a shared electron. That makes a covalent bond, and we'll study that next week. The rules for naming these compounds and for working with them and their properties are different from ionic compounds to covalent compounds, and I'll try to show you a little more of that too. And then and I hope you have a good week. This week, week 3, week 4 aren't too bad. Week 5 is kind of the next hard week that we'll run into, and I wish you luck. Hi, I want to talk a little bit about naming of ionic compounds, and I put a few notes here. One that reads, oxidation states of ions can affect the name of a compound. So you might want to ask, what is an oxidation state? How does that differ from a charge? Well, if an ion, and remember an ion is something that carries a positive or negative charge, and an ion, if it is positively charged, it's a cation. So remember that. So if it's positively charged, it's a cation. And if it's negatively charged, it's called an anion. Both of these are the ions. This is the class of compounds called ions. You have the cations and the anions. So anions are like you can remember A negative ion. So they're named a little bit differently. So for example, S2 minus. So S2 minus, is this an anion or a cation? Well, that's negative, so it's an anion. It's a sulfur with a -2 oxidation state. So we're going to say this is a -2 oxidation state. Now you might think oxidation state has something to do with oxygen, and you would be wrong. It doesn't. There's historical reasons for that, but we sometimes call this its charge, but we're going to say that it is its oxidation state here. So that's the oxidation state. Cations and anions are named differently. If a cation is the most common or only oxidation state of the element, then the cation is given the name of the element. For example, Mg for a cation now. This was just an example of an ion. I'm talking about a cation. For a cation, if it's a single thing, it's just Mg, there's nothing else on it, meaning that it's not something like, one example would be NH4, which is a cation with more than one atom in it. That would be called a polyatomic cation. If it's a monoatomic cation, a monoatomic cation, then it's just named the name of the stuff. So this is just called the magnesium cation, or we just call it magnesium cation, if that's the case. So, but if the atom's an anion, and I'll change colors here, and I will erase some stuff so we can see a little better what's going on here. So if it is an anion, let's erase some more here. It's kind of fun. So I will change to red. So if it is an anion, remember, if it's a cation, a single cation, then you just call it the name of whatever it is. Pretty easy. So, you know, some examples, those I'll give you in a minute. So if it is an anion, however, for example, like I started earlier, which is have S2 minus, then you change the end from sulfur, so you keep the prefix and the suffix changed to ide. So if an anion is S2 minus, this goes from sulfur to, we call this the sulfide anion. And so, you know, other examples are Br minus is bromide, for example. And, well, we'll continue. Cl minus is chloride, for example. And oxygen, which is O2 minus, is oxide. Those are some ways that you can remember. If it'll change colors here to talk about some examples of some of the cations we have. This is just, we just call this one is just called, guess what? Just called barium. And this is just called, now they might have more than one oxidation state. It gets a little tricky there. This is called cobalt. It gets a little trickier when there are two different, or at least there are more than one oxidation state, which there are in the case of metals. And these ones you just sort of have to memorize those, and they're listed in your book. For example, if there were two oxidation states of copper, and there are, and we have confusingly two ways of naming them. So you have copper 2 plus and you have copper 1 plus, because and the higher oxidation state ends in ic, and the lower one ends in us. And that's one way to remember it. So this is the old style, old naming convention, and this is the new hotness naming convention over here. We would call this the cupric ion, and this is called the cuprous ion. But nowadays they're called we call them copper 2, and we call this one copper 1. You have to know both methods because some people hanging on to the old methods. So some other examples of these sort of multi-charged, multi-oxidation state naming compounds are, another example is, let's say we could do, let's go back to this, we'll do iron. And iron also has a couple of oxidation states. There's iron 3 plus, iron 3 plus, and there's an iron 2 plus. Now notice it's not, remember copper was 1 and 2. This is iron 3 and 2. And this is still called, the ferric cation, and this is called the ferrous cation. And this is also called, we call this iron 3, and we call this iron 2. So for naming these higher and lower oxidation states can have slightly different names. But if you had something like, just like this sodium, you would just call this sodium. There are tables in your book that help you to know which one to call when. So next I'll do a little video on how to name these compounds. Hi, so I'm going to give you some tips on how to name ionic compounds. That's one of the biggest things that students have problems with. So here's some things to ask yourself. I may not be looking at the camera the whole time as I'm reading some of my notes, but here's what you look over, and I'll go over this with you with some examples. So the first thing you look at is how many elements are in the formula. So you divide the formula into two parts, a left and a right side, by looking at the number of elements there are. If there are 2 elements, the first element will be a metal. So the left one will always be a metal. You're also going to want to memorize your table of polyatomic ions, and we'll go over that later, but you should memorize that table to make your life a lot easier. If there are 3 or more elements in your formula, pretty much guaranteed you have a polyatomic ion. And you need to know their names and their charges. So what is the name of the cation? If you find the cation, this one on the left, the metal, what is the name of that thing? You can name the first element. If it's a single element, just call it by its name, like sodium, potassium, barium, whatever. And if the formula begins with, like, say, NH4, that means, like, NH4, for example, is not an element. It is one of the polyatomic ions I told you about. This is called the ammonia polyatomic ion. And so that will help you determine if the compound is ionic or covalent if they're from the left and the right sides of the periodic table. So if it's only 2 things, like NaCl, and the Na is from the left side, the Cl is from the right side, that's a very good indication that it is an ionic compound. The further apart the things are on the periodic table, the more likely they are to be ionic. And I'll give you some better rules for that later. So is a Roman numeral needed after your ions? Remember we talked about copper and iron having potential need for Roman numerals or different types of naming, like the IC-US system. And there's a list in your book that you need to memorize that has all the different metal ions and tells you if they are, if they need to know the oxidation state for different naming. There's a table in your book. Look at the table. See, it's just, I don't remember the exact name of the table, but it should be obvious. Then you can determine the oxidation state that is needed from the charges, and then you ask what is the name of the anion. Look, and you can name the anion for the second element, or the one on the right, or the polyatomic ion, which you'll have a list of. And then you put the 2 names together, and that's the name of the compound. So I'm going to do a few examples here for you really quickly. So the first one I'm going to do is, what is the name of this compound? What would you call this stuff? Right, that one's pretty easy. So I'm going to go over this with you. So determine how many elements are in the formula. There are 1, 2. I would call this 2 elements. All right. So find the name of the cation. The name of the cation, I'm looking on my periodic table. I see that over here the name of this one is sodium. It is called sodium. Sodium. And then I determine whether or not a Roman numeral is needed. It is not needed because he's sad he doesn't need a Roman numeral. There's no Roman numerals needed in this case because we know nothing in group 1 or group 2 of the periodic table has more than one oxidation state, and that's and it's not on the table that we have in our book. So that is a fact. So the answer for this guy is going to be just no. What is the name of the anion? So I'm seeing chlorine. This is the chlorine atom, but we take that off and we change it to "ide" because it's an anion, so we call it the chloride anion. And so the name of the what's the name of the compound? The name of the compound is sodium chloride. That's one. So that's one example. Let's do some more here. I need to get a better eraser on this guy. Erase faster. All right, so sodium chloride. So let's do another problem. So what is the name of, let's say, this one here? Let's do this one. Let's go with, I'll change the color slightly. Let's go with FeO. So the question here is, how many elements are there? There's 1, 2. There's 2, and they're from, and this helps us to determine, the reason we ask this question is it helps us determine whether or not it is ionic or covalent. If they have 2, they're always going to be ionic. If there's lots more, then they might be covalent. So determine what is the name of the cation. Well, let's look at this one here. So the first one is it's iron. So we find the name Fe. We look on the periodic table. It is called iron. Is a Roman numeral needed? Well, we look on the periodic table to see how many oxidation states there are for iron. Now, it's a periodic table that you have in your book. It's also a small section of our periodic table that tells you that iron has 2 oxidation state. So yes, a Roman numeral is needed. We found this out by looking in our book. This we have to find out what the charge of. There are two. There's an Fe3 plus and an Fe2 plus. There's a ferric and a ferrous. We have to find out which one this is. And what is the name of the anion? Well, it's oxygen. Oxygen. That's changed to oxide because it's an anion. So that's called an oxide. And so we have to figure out which of these it is, which of these two ions are, and what is the name of the compound. So oxygen always has a charge of 2 minus, and we're looking at which iron would exactly cancel out a 2 minus to give a neutral charge. There's no charge overall in this ion. Well, it would be 2 plus. So the name of this compound, it would, if it were 3, it'd be something else. So the name of this compound is called iron 2 oxide. It's also called, this is ferric, so this is ferrous oxide, ferrous oxide. And I'll give you another example here once I erase this stuff off of here. We'll do another one and get rid of some more of these guys. And again, this little step of how many elements are in the formula is made largely to help us try to understand if it's ionic or covalent. It'll come more into play next week. So let's do another one. And the next one, let's say that it is Fe2O3. Let's change colors yet again. I'll give you orange this time. So it's Fe2O3. How many elements are in the formula? 2. So it's more likely to be ionic. What is the name of the cation? It is iron. Is a Roman numeral needed? Yes, we know that already. So we'll have to find out in a minute which one this is. What is the name of the anion? It's oxygen, so we call it the oxide anion. Now we have this puzzle. We know that there are 3 oxygens, and they always come in at 2 minus. They're not multivalent, so there's just the one. We have 3 times 2 minus is equal to 6 minus. So because the entire thing is neutral, we need to know that there are 2 irons here. 2 times question mark is equal to 6 plus. And that's the charge on the iron. So that what's the charge? So 6 divided by 2 is 3 plus. So the answer is 3 plus. So it must be iron 3 plus. And I will cut this out and move it so that you can still see it, but I'll have some room to write here. Whoops, hello. So what we're going to do is we say that, so if it is Fe2O3, we know this is iron something, that's oxide, then which iron is it is the question. Another thing you can do is called the reverse crisscross applesauce method. Just put the 3 here up here and the 2 there, and you're going to end up with iron 3. So it's called ferric oxide or iron 3 oxide. That's how. I'll do one more, a little bit harder one for you in the naming business here. One more. And let's see here. All right, so let's see, I have NH4,3PO4, so it's a little harder maybe. Maybe not. This one has some ionic compounds, so it's going to be NH4 parentheses 3, because that means 3 NH4s, so there's 3 N's and 12 H's, and then we say that they're PO4. So that's the we recognize this from our book, A Table of Polyatomic Ions, as being of the ammonia cation and the phosphate anion. How many elements are in the formula? A lot. 1, 2, 3, 4. This is more complicated, so we're going to either need to identify this as being a covalent compound, or we're going to have to recognize the polyatomic ions and to name it appropriately. So What is the name of the cation? If we find it in our table, we find this in the table in our book, and the NH4 was revealed to us to be called the ammonia cation. And Roman numeral needed. No, there's only one charge, again, by our book. What is the name of the anion? It is called, in this case, it is called the phosphate ion. So it's phosphate, so it's PO4 3 minus. PO4 3 minus. And it is called the phosphate. And what is the name of the compound? Well, it is simply ammonia phosphate. Now, how do we know how to write it like this? Let's say we didn't know what the formula was. Ammonia phosphate. How would we write, if we just had this word ammonia phosphate, how would we write the formula, which is up here? I'll move this out of the way. We would start with the NH4 having a charge of 1 plus, and the PO4 having a charge of 3 minus. And one way that only works if you reduce it to the lowest common denominator is to say we do the crisscross applesauce method. We say NH4, and then we put a 3 down here, and then there's a 1 here, so it doesn't really change anything. You don't write a 1 on it. And then you get, and I'll have to write it over here, you get NH4 3 PO4, and that's the name of ammonium phosphate. So I hope that this helps at least a little bit. I know it can be confusing and you need lots of practice, but anyway, I hope it's fun. Take care and enjoy. Hi everybody, it's me again. I just wanted to give you a little more practice in writing the formula from the name of a compound, since I realized I really didn't do that much so far in this course. So let's start with the first one. So magnesium chloride. I'm going to just go through these really fast. It won't take much time. And you may enjoy watching similar YouTube videos than what I'm doing anyway, but I feel like I should do it for you too. So find the symbols for each word in the name. So magnesium is, we look on the periodic table, that's Mg. And chloride, you have to find chlorine because it comes from chlorine, it's Cl. Then you have to figure out what the charges are on each. The magnesium comes from the second row in the periodic table, and its charge is 2 plus. Chloride comes from group 7, so its charge 1 minus. And how many does it take to, they must be neutral, so the charges altogether, charges must sum to 0. So we can change that sum by putting numbers in the front here, which are called coefficients, and then we can use those to balance them. The numbers end up being on the bottom. So we're going to use 1 magnesium, gives us a 2 plus, and 2 Cl minuses gives us a 2 minus, a 2 plus, and a plus, a 2 minus, plus a 2 minus equals to 0. So we'll say that we had 2 chlorides. So how do we write magnesium? MgCl2 is the answer. We could have also used what I call the crisscross applesauce method in this case. So we have a 2 plus here. We write that down there, write the 1 down here, and we end up with MgCl2. That's magnesium chloride. Lead nitrate, a little tougher, this one. So we need to find the symbols for the word in the name. And if we get lead, we can get that straight off the PTE Express, the periodic table of the elements. And lead is from plumbum. It's a Latin root, so it is Pb. And nitrate is a little harder. We might have to look for this one. You might have to, Wikipedia that or something, or look. It's in the table of polyatomic ions. It is for sure. It's not on the periodic table of polyatomic ions. And again, you might Google it as well. I wonder what I would get if I Googled that. But I promise to make this quick, so I won't do it. So, but nitrate and lead, we have to find out what charge it has too, don't forget. So, and we find out this is NO3, okay, for nitrate. And we have to determine how many of each one of these we need now. That's the kind of the hardest part of this whole thing, is how many do we need, and what are the charges going to be. So the formula for lead isn't multivalent. It's always just lead 2+. And the formula for nitrate is just 1- all the time, so we don't have to worry about balancing it too much. I'll change colors here. The crisscross applesauce method will suffice in this case. And so when writing this down, we would say PB, just a 1, so we don't write anything. And then we say in left parentheses NO3 2, and that's lead nitrate. Silver carbonate goes a very similar way. Silver just has the 1 charge on it. It's silver plus, and we have carbonate is CO3 2-. So we crisscross applesauce it here, and we have AgCO3 2 is the formula for silver carbonate. I know it's just brief, but I hope it helps you very much. Take care. Good luck.